Hi. Oxidation number in oxidation state, these both are mostly used with the same sense, but there is little difference. We will discuss this aspect that there is little difference in the oxidation number in the oxidation state. I will say the two things. What is the oxidation number and how it is little different from the oxidation state. I don't want to go in much detail. Oxidation number is exactly the true charge in the case of monoatomic ionic species. At oxidation number or oxidation state is the true charge, actual charge in the case of monoatomic ionic species. Monoatomic ionic species means you will take here Na plus, Mg2 plus, O minus 2, Na plus, Mg2 plus, there that O minus 2. Exactly, these are the monoatomic ionic species. For polyatomic ionic species or polyatomic molecule, oxidation number is one of the assumed charge in one of the condition of heterolytic cleavage. Means the charge is assumed when there is a heterolytic cleavage. There are two types of cleavage. I hope you remember. Homolytic and heterolytic. When heterolytic cleavage takes place, there more electronegative atom retains that bonded pair of electrons. Right? And the same thing, in that condition of heterolytic cleavage, what charge is assumed, charge is formed on that particular atom, that is the oxidation number. I just give one example. In one example, everything you will understand. Here I write H2SO5, H O S double bond O, double bond O, NO, NO in there H. This is H2SO5. If we have to find here the oxidation number of hydrogen, very simple. We assume here heterolytic cleavage. Heterolytic cleavage, it means this one is more electronegative, this one is minus 1, this one is plus 1. So its oxidation number is plus 1. But for the oxygen, if we need to find, then we have to take the complete heterolytic cleavage, means all bonded atoms. So here also and there also we have to use. In this case, there we get minus 1 and there we get the plus 1. Why minus 1 on the cleavage of this one? Because oxygen is more electronegative than the sulfur. Same thing. So for this oxygen, minus 1 from this side, minus 1 from this side, total charge, assumed charge is minus 2, that is its oxidation number. What about the sulfur? Let's check there the sulfur also. When we break this bond, as usual, this one will have minus 1, this will have plus 1. When we break here the two bonds with oxygen, then there is the minus 2, there is the plus 2. When we break here, minus 2 and there the plus 2. One bond we break, minus 1, plus 1. Two bonds we break, minus 2, plus 2. Now, in this case, what is the total charge? Total charge on this sulfur, assumed charge on the sulfur. Plus 2, plus 2, plus 4, plus 5, plus 6. Yes. It is plus 6. Sulfur plus 6. For the sulfur plus 6. Assumed charge. For this oxygen, -2. For that oxygen, -2. What about this another oxygen? Another oxygen, the same thing, we continue. There, if you break this one, we observe that there is no chance of heterolytic cleavage. Why? Homoatomic bond. Oxygen and oxygen. No one is more electronegative, less electronegative, both are same. That's why in this case charge is 0. Their charge is 0. On this cleavage there is no charge. But when we come for this oxygen, then again we get here -1 and the other +1. Now, if the question is what is the oxidation number of this oxygen? -1. Oxidation number of that one? -1. Oxidation number of this hydrogen? +1. Oxidation number is assumed charge in the condition of complete heterolytic cleavage. Interesting thing is this, that in this case the oxygen, we have the two different kind of oxidatives. Some of the oxygen atoms have -2 oxidation number. Some of the oxygen atoms have -1. Sulfur +6, hydrogen +1, +1. In this case, when you write here, molecule given like this, H2SO5, what is the oxidation number of oxygen? Now you don't know that which oxygen, right? O5 given, they are the 5 oxygen atoms, you don't know. Then you take the average of oxidation number of all the oxygen atoms in the molecule, right? And what is that? Oxygen is -2, -2, -2. Total is -2, -2, -4, -6, -7, -8. And so this one is -8 by 5. This is the oxidation state of oxygen in this H2SO5. We have taken the average. Although here in true sense we have the different kind of oxidation number for different oxygen atoms. This is the basic difference in oxidation number and oxidation state. These atoms have the different oxidation number, but when we take here the oxidation state, we take the average. Okay? And this is the right conceptual way to think and understand oxidation number. Right? I hope you got this one. Enjoy. Thank you.